how many people have worked with Hadoop or distributed systems before? Okay, fantastic. I targeted this talk correctly because it's about people that are thinking about doing it or don't know about it or curious about it and want to know more about it. So the way that this talk came about is, let me see, yeah. So I've done a bunch of Hadoop projects. I worked on 3 or 4 different projects over the past 5 years. And I've started to see some patterns develop, so I wanted to give a talk about cases when you actually should use Hadoop versus cases when you shouldn't use Hadoop. So the first half of this talk is going to be about actually how you can do big data on your own laptop. Like, you don't need to set up a whole distributed system, a whole distributed cluster. Sometimes the old way of doing things is actually just as efficient or even more efficient. And then I'm going to talk about if you actually do decide to or have a need to do big data on a cluster, what kinds of things you should think about. Like, what are the pros of doing big data in distributed systems? What you should look at in Hadoop internally, like file formats. And then Spark development, because Spark is really important in the Hadoop ecosystem right now. So I wanted to talk a little bit about that as well. So it's kind of going to be half big data bad and half big data good, but you should think about some of this stuff. So the first thing to kind of think about is, let's say you're thinking about developing or architecting a big data system. You don't always have big data when you start out. So there was this website a couple years ago called yourdatafitsinram.com. And you could pretty much put in a value of how much data you had, like terabytes, megabytes, etc. And it would calculate that against the size of like a commodity Dell server. And it would say, you don't actually need a distributed system because you can run all of your operations on one server. And so after seeing that and my own data experience and then talking to other people, I came with this very scientific sliding scale of things that you can do before you need to get to the big data point. And for me personally, that's been like, if you need to process any less than 10 gigabytes at a time, you probably don't need any distributed systems, and you might not even need a database, depending on how that looks. So if you have really, really tiny data, like you just have some business analysis that you want to do, if you're at the point where you're emailing files, you don't need anything. You just can do it in Excel, which I know Excel is a terrible application. And I kind of want to burn it to the ground sometimes, but sometimes it is the best tool, and it's easy for a bunch of different people in any company to work with. And then if you don't want to use Excel, you can use command line tools. So that's what I'm going to talk about. Then once you get a little bit bigger, you can maybe move into the scientific Python stack. So you can do analysis in pandas, and it's really cool because now you're at the point with pandas and the command line where you can do reproducible research instead of just putting formulas into Excels. And then maybe you get to the point where now you're in a database where you have tables that you need to join, which is not really easy to do programmatically. Now you want to put your data maybe in Postgres, and notice that this is still on one machine, which could potentially be your laptop. And here, when you get into gigabytes, it might make sense to start using Spark, which you can also do locally. So you can download Spark and do some of this processing locally. And then once you get to maybe 100 gigs of data that you need to process once or even every day, then you want to start thinking about setting up a Hadoop or Spark cluster, or Cassandra, or any other distributed system you want to think about. And then for anything past that, you probably do want to use Hadoop. But my point is, up to here, you don't actually get any gains from setting up Hadoop. And in fact, it actually makes your system more inefficient, which I'm going to go into in detail. So you want to think about what your organization has and doesn't have. So I'm going to take you through an exercise that I did with a data set. So word count. MAPREDUCE is usually like the most common exercise that you do for distributed systems these days. And I decided to go with Les Miserables because Les Miserables is awesome. And I've been watching it on repeat for the past couple weeks, so I can't get this song out of my head. But also because Les Miserables is a really big text file. It's one of the top longest novels in the English language. I think it's like number 4 or number 5. So it has over 600,000 words, and it's like one of the largest single text files you can have out of a book. So it's 3.2 megabytes. So if you have one of these, you probably don't need a lot of processing power. And let's say you want to process like the characters' names, and you want to do a simple word count. So let's go back a little bit and ask how much can your laptop process? Let's say you have like random laptop, like I have a 2015 MacBook Pro. So there was a study done that said basically for 40 to 80% of jobs submitted on MapReduce systems, you're better off just running them on a single machine because of the inefficiencies. And then Databricks, which now sells kind of Spark in a box, they released their processing engine Tungsten last year, which basically does aggregation joins on 1 billion records on one machine in less than a second. I don't know if I necessarily believe this, and you can check out the links too. Like they have this whole blog post about Apache Spark as a compiler, and you can read all about how they did it and all of their claims, and it has all of their code. So I don't know if I necessarily believe that, but even if it's half as fast as they say, that's super impressive. And then there was another post where a guy basically took 1.75 gigabytes of data of chess games, and he wanted to see how long it would take to analyze it in Hadoop versus on his own machine. And he created a Unix pipeline using xargs and mock. And xargs parallelized stuff, and mock was a more efficient version of awk. And he basically got that data processed in 12 seconds. And it took him something like, I think, 26 minutes to stand up a Hadoop cluster, put the data in the Hadoop cluster, write the MapReduce, all of that, and then he wrote the xargs and mock job. I mean, he probably was already very familiar with the tool set, but yeah. So this was what he ended up doing. He did a bunch of optimizations. So this is the one at the bottom that he ended up going with, and it took him 12 seconds. So he did all of that on his machine. So that's almost 2 gigs of data that he could process locally and not have any inefficiencies. OK, so back to our file, Les Miserables. So all I did was I went to the Gutenberg library, free source, and I downloaded the file, and then I just checked it out. OK, so yeah, Les Miserables. You can see it's like just the basic text file, nothing fancy. So then if you wanted to do MapReduce in just the command line, you could do it if you wanted to with this one file. So there's a bunch of stuff going on here, but basically all of this stuff, let's see if you can see that, is doing ETL on the file. So it's replacing all the lines with spaces. It's converting all the spaces to line breaks, so each word is on its own line, so you can count it easier. It's removing all the uppercases, so all the words are counted the same. Like if you have the in uppercase and lowercase, it's the same. And then it sorts it alphabetically, and it does, so here's where you're really counting the unique occurrences here. This is like kind of like your group by. And then you're sorting it, and then what you get out in the end is this. So this is the number of the word. So you have line numbers. This is how many occurrences there are, and this is what the word is. So Marius occurred 1,374 times in this file itself. And so you don't need any MapReduce. It's probably going to take you some time to come up with this pipe expression, but probably not as much time as it takes up to set up a cluster. And also, I was really surprised that Marius is more popular than Valjean, because I actually really hate Marius in the book and the musical. Which I thought was interesting. So if you want to do any business analysis on that, that would be really cool to do. And then, OK, so you have command line MapReduce. But what if you have a lot of these files? Let's say you have 1,000 of these Les Miserables files, or 2,000 of these files, which is what you would usually have if you have log data, or you have healthcare data, or you have financial data, or any type of data in a business. You're not just going to have one file to process, right? So then you can write your own MapReduce in Python, and you don't actually need to, because I wrote it, and other people have written it a million times before. And so I have the code on GitHub. Again, and this is on my Twitter and website, and I'll leave the link up afterwards if you want to take a look at it. Yep, so literally this is like 115 miles of code, or 115 lines of code. And then you have like 5 or 6 functions. And so the key is here, where you're creating a Python dictionary as a result set, and you're saying you look at all of the words in the file, and if they don't exist, you add them to the dictionary, and if they do exist, you add a counter. So you increment a counter. And so that's literally what MAPREDUCE is at the heart of it. And in Java and any other programming language, it would be something very similar to this. So this is really like the algorithm of what MAPREDUCE is. And so like this is actually what's fueled the hype cycle of Hadoop for the last 5 or 6 years, which is kind of funny when you think about it, right? Because it's pretty easy. So then you can write this little program that does MAPREDUCE. And then the reason that I decided to use Python, other than the fact that Python is the best programming language in the world, is you can also do parallel processing. And so you can see that here. So you have the pool object, and you can spawn a number of different processes to run all this stuff in parallel, which is kind of the same thing that xargs does on the command line. And then you can map it, right? And so now I ran these, and I ran these in PyPy because PyPy is just faster and awesome. So I have a program called mapreduce.py. This is the size of the files that I ran it on. So I think this was like 1,000 Les Miserables. So it was 3.1 files. It took me almost 3 minutes to process that. And then I said, let's generate some more files. So I generated 2,000 files, which came out to 6 gigs. And that took 4.5 minutes to run on my machine. And I didn't do any tweaking, because you can tweak the number of processes here. And you can play around with it. You can also change the chunk size too, although that didn't seem to matter as much. And so in this case, I got the same thing, only more nicely formatted. And you can see there's a lot more Valjans and Marius, because now I have 2,000 files or so. So the same exact thing, and then you can see like all the usual words you would see. And what I find interesting here is that Valjean has more than Jean's. That's just my own little like lamest takeaway from that. So if you wanted more control over the processes, and if you wanted to be a little more reproducible than the command line stuff, and if you have a lot more files, you could just do it in Python, or scripting language, or programming language on your choice locally. So then, if you want to get all hipster and try Spark, you can try Spark. So you would just download Spark, build it locally, and then you would do this thing here at the bottom. I'm not sure how well you can see that, but it says Spark submit, and then you could write a Spark word count application. So let me show you that. So this is a lot less code. So I had like 115 lines in the Python file. This is literally like maybe 10 or 11 different lines, a lot more Lambda. Fun, but you notice we're doing the same exact stuff. We're doing the replacing of this stuff, the ETL, we're splitting it, and then we're mapping and reducing and sorting, and then we get all the same stuff as well. So the downside with this is it took me maybe like 15 or 20 minutes to run this locally, because A, it wasn't optimized, and B, Spark works a little bit differently. So now when you have Spark, you have a distributed system that's now running it. So it has a lot of distributed system overhead. So you have task schedulers and Spark context and drivers, and it has to listen to different stuff and executors. So if you don't have enough data, it doesn't make sense. So when you have distributed systems, they need to listen to different parts of the process, which adds overhead, which is the whole overhead part I was talking about. Whereas with Python, you just have like 3 threads that you spawn, and then it has the global interpreter that overlooks it. So Spark is a lot easier to write, but has more overhead in the end. But you could still do all of this locally, and you could tune it. And so here I had 5. So this is how many cores theoretically you're running. So here I had 5 that I was working with. Okay. So the issue here is, so you can do all of this stuff locally. You can do it on command line. You can do it with your programming language of choice. You can also do it with Spark. So you could process 6 gigs of data easily on your own in the time it takes to spawn up a process. The other thing you want to think about is how much more accuracy can big data give you? Like if you want to actually collect all of your data, do you actually want that data or not? And so here you might want to take a look at the margin of error. And so the margin of error usually looks something like this, because it's exponential, right? It's divided by the square root. And it basically looks at the reliability of the data, and it says if the data is unbiased, what's the difference between the sample and the population? So you can see as the sample size grows, the margin of error decreases, obviously, because it's closer to what your actual population is in size. But at a certain point, you only get small improvements, right? So do you actually want to collect this much data and have it be like 0.03% more accurate? Like, what's the trade-off effort that you're looking at there? So that's something you might want to think about, and you might want to think about, if you can, sampling your data instead of collecting all of it. And of course, you have to be careful how do you do that, because it might not be representative of the population. But if you think it could be, then you can do that as well, and then you can continue to process locally. Okay. So that was local. So again, continuing on the big data hate train a little bit. There's some other stuff that big data can't give you, and so a lot of the stuff I talked about was just in the context of raw text files. But from a database perspective, big data cannot give you data integrity, because when you put data into a big data system, you're not putting it into a database, you're just putting it into a file system. So you're just kind of like throwing stuff in, right? So the way I kind of think about it as an analogy is, when you have a relational database, you have books on a shelf, and they're sorted by a very specific order. And it takes a while to order them correctly, because let's say you need AB, and you need to look between AA and AC, and you need to put that book in. So that takes a while, but then you can get it out right away. When you have big data, you're basically ripping out all the pages of the books, and you're just kind of like throwing it in a pile. And that's much faster to move somewhere, but it's harder to look through. So that's what you're giving up there. And then there's no naming conventions. There's nothing set up until you actually set up, because so you don't want to do that. And then it also increases the amount of time it takes your business analysts or what have you to actually query and make sense of this data. Again, because it is disorganized, and you're not defining a schema until you actually need to read it. So that's a hang up. And then there's no traditional data guarantees of consistency. So distributed systems are eventually consistent, but they're not going to be consistent right at some point, right? So big data is not a transactional database, and it can't give you the things that traditional databases would be able to give you. And additionally, you also want to look at the cost of a system. So there's this paper that basically looks at all the overhead that I talked about with Spark, of how much it takes to set up one of these systems and what kinds of costs are associated with it. So you can check out that paper once you look at the link. But there's a lot that big data can do for you. So there's a lot of cons, or a lot of what I like to think of as trade-offs more than cons. But there's a lot of pros that you're getting when you actually do get to the level of a distributed system. For example, if you have unstructured data, videos, pictures, XML blobs, because I know how much we all love XML blobs. If you have anything like that, you can just throw it into HDFS, and it'll store in there just fine. And then you can process it later on. So it's much easier with that. If your single server of Oracle goes down, you're out of luck, right? But if a node on Hadoop goes down, it has replication. So it has fault tolerance and availability, which is why it allows companies like, well, not lately Amazon, but Amazon. But that was a manual error. Amazon and Netflix to operate with the amount of uptime that they do have. If you're just building out something like a data lake, it's a great case for having data in a lot of different departments in one place, because it's relatively easy to get into Hadoop, as opposed to you have like 5 different databases systems, and then you have a CSV file on someone's laptop. So if you're starting from scratch, it's a fantastic way to centralize all of the data in the company. And if you have a lot of people querying it, it's really great for that, because it is distributed. And then ability to programmatically work with the data. SQL is amazing, and SQL is my first love, but you don't always have that, or you don't want to work with it that way. So you have a tool set of Java, Python, what have you, to work with all this stuff on top of HiveQL, which is like SQL. So this is just kind of a reiteration, but these are more specific things. Another thing to understand is that if you have a lot of people to work on this, it's a very good case for you because a Hadoop setup requires at least 1 or 2 developers, 1 admin, and 1 analyst. So you have to factor that in because it's a distributed system. There's a lot of complications. One person can't do the work of all of it. So that's important to know as well. So here are actually 2 cases when Hadoop would be fantastic for. The first one, again, is Netflix. Right now, I think they have a 10 petabyte warehouse. Yeah, you're probably not going to be able to store that in Postgres, no matter how amazing it is. They have a lot of analysts performing a lot of queries on it. And they also have a lot of data that needs to go through to somewhere else. They've grown from 10 to 80 million members, and I think that was like in 5 years. And they also have lots of devices, because think about like how many, if you watch Netflix, you watch it on your phone, your iPad, your computer, all that kind of stuff. So they need to keep track of all of that, and they need to analyze user intent because they need to better calibrate what content people care about, and they need to be up all the time so you can watch, like binge watch, whatever you want to binge watch. So Netflix is a really fantastic case for Hadoop or distributed systems in general. The other cool one is, like out of the commercial space, is the Sloan Digital Sky Survey. And I thought this was pretty cool because I hadn't seen this before. It has 3-dimensional maps of the universe, basically. So they're trying to take pictures of like every part of everything that you can see in the sky with super crazy telescopes. So they have 250 million stars, 200 million galaxies. And scientists use this for research or for academic papers, and there's tons of scientists using it. These pictures are really high resolution, high quality. So this would be a good use case for a distributed system. Okay, so if you have a distributed system, there's things that you can do to make sure that it all goes smoothly. First of all, from the admin side, when you set it up, you need to do a lot of optimizations. For example, the naming conventions, like I said, there's none initially because it's just a file system. So if you want to name it file 123 or 123 file, you can name it whatever you want, and then you're going to have a crazy mess. So you need to standardize on that beforehand, like with the architect. And there's also a lot of security issues because this is a distributed system, so there's a lot of ways potentially for people to come in over the network and from other places. And then again, the team size, you need to make sure you have the right team set up for it. And internally, 2 things I'm going to talk about quickly are the file formats you want to check for Hadoop and the kind of programming languages that you want to use in it. So there's a ton of file formats in Hadoop. I think there was something like 10 or 11 last time I counted, and there's like seriously a new file format every day. But the 3 major ones you want to look at if you do is Avro, Parquet, and ORC. And all 3 of them are slightly different, and they have slightly different use cases. So like on your laptop, you might store a file in CSV or TXT. In Hadoop, that's really inefficient because it deals much better with compressed files that are structured a certain way. So all 3 of these file formats work better in Hadoop than any traditional file format. So Avro is better for row-based. And ORC are pretty columnar. And yeah, and Parquet is good, again, for feature selection if you're doing a lot of data science. But again, it really depends on your use case. And another fun part is each of these has its own compression format that it works with better. So it's really like you have to play around with your data and see what the use case is and see which compression format and see which file format works better with it. Because in some cases, you might get optimizations of like 25 times if you choose the right or wrong format. So that's really important to do research on. And the other one is Spark development languages. So Spark is huge in the Hadoop platform right now. It's actually replacing MAPREDUCE as the processing engine, so it's going to become even bigger and bigger. And so now the kind of fight is over which language you're going to use for Spark. So this was for Spark Summit 2016, which is the summit that Databricks, the company that owns Spark, and the guy that invented it owns Databricks, put on. And so in 2014, when Spark was like a year old, which was, it was young then, and now it's mature in 2017. So 84% of the development was in Sky, which also this doesn't add up. so it's kind of making me twitchy, but I guess people like, this was a survey of check everything that you use. So Scala was huge because Spark is native to Scala and because that's what all the examples were written in. But also nobody knows Scala, and a lot of people don't like Scala, and a lot of people are more efficient in Java. Well, this doesn't prove that, but it does prove that Python has grown a lot more. And now R, people are starting to do development in R too, although this is really, really young at this point. So there's a lot of questions about like what language you should use for development in Spark, in Hadoop itself. And so in some cases, like if you're a team, so traditionally what I've seen is you have a team of all Java developers that are moving on to Spark, and they have to learn Scala, like not from the ground up, but they have to learn a lot about Scala, and it would be more efficient for them to use Java 8, which now is starting to contain Lambda expression in a language they already know. And Scala also still has a lot of compile time overhead. There's also this thing about Python being slow, and it's not necessarily slow in all use cases. And so you also want to take a look at the fact that like a lot of people want to use Python. So this is something that you want to consider too. So I think, yeah, so that was my entire presentation, but I guess the main thing that I want you to take away from it is, yeah, and there's some resources here too, so let me leave my site up at the beginning. There's a lot of trade-offs that you make, and there's a lot of choices, and you basically need to understand those choices when you're choosing a big data system so that you get the most out of it. That's it. Questions? Do we have time for questions?
I do have a question. Do you think Spark helps developers understand distributed systems better than, say, working with just separate threads in Python or other systems? Does it create an abstraction that helps people do this better?
It helps create the abstraction because the API is easier to use, but it definitely does not help them understand it better because it introduces a new layer of RDDs. Like you have to understand how RDDs work, which is different from how MAPREDUCE works. So it's like another thing that you have to learn.
What's an RDD?
RDD is the atomic unit of processing in Spark. It's kind of like a data frame or a table in memory. A memory table is the way I would describe it.
Do you see like hybrid systems where you would like store, data that's used very often in, another system where, you could get it out quicker and doesn't have the overhead, and then move it to big data systems? I do a lot of IoT work, and that seems like how things are moving.
Yeah, there's a lot of hybrid work. So I don't think I've ever worked with any system where they're like, okay, Hadoop, and here's all you have. It's usually like, oh, we have Teradata, and we want to move it into Hadoop, and we want to move it out in MySQL, or we want to move it to a front-end thing. So it's never usually just like you have this as a standalone thing. You also have to consider that you're working with other inputs and outputs, and that adds overhead as well, right? Because you have to get it out and in. So that's a very good point, yeah. Yeah, so there's Hue, which works real well for HiveQL and some other type stuff. Yeah, that's the big one. I wouldn't say it works great with a lot of other stuff, but it works relatively well enough at this point that you can use it.
In your own experience using Spark, what's like the biggest headache? Just like the thing that comes up the most common is like instant migraine, if there is one.
Everything about Spark. It has a pretty steep learning curve from the point of view like this is how you should do things in Spark, and it's learning about like how to optimize it correctly. Like even here where I have where was it? Setting the master to 5. Like why is it 5? What do all these things mean? How do you actually get like the most out of Spark so that it processes correctly and it splits your data up into chunks correctly? I would say that's the biggest thing.
Mostly tuning issues.
Tuning, yeah, tuning.
So if you're brand new to this, what's the trajectory that you recommend? Look at this first and kind of get a good grip on this, and then move on to these things eventually.
Well, what's your background? Not to put you on the spot, but I'm sorry?
Cybersecurity.
Okay.
So, I'm actually just diving into programming in general.
Oh, okay.
Initial,
You're diving in the deep end.
I am. So this is obviously very interesting to me. And
Yeah.
It's fairly good things to know. So I do work in tech, so I'm very familiar with it. I just don't get hands-on.
I would recommend starting with the Cloudera Quick Start VM. So Cloudera is a vendor of Hadoop. There's several vendors. There's MapR, Hortonworks, Cloudera, and like a couple of other ones. But they have a VM set up with all this stuff already pre-installed, and you can run it locally. And they have a bunch of examples that you can work out locally, because it's a lot of overhead to also set this up, and you have to tune Unix and Linux and ports and all this stuff. So I'm actually trying to run Hadoop out of a Docker container for work right now, which is like terrible. But Cloudera packages it in a nice way that it's all self-contained, and you can practice and not worry about breaking anything because you can just reinstall it.
They have community edition?
It's free, yeah. You can just get it, yeah. Cloudera Quick Start VM.
Can we dig back into your personal experiences a little bit more? Could
Yeah.
you give us a couple examples of data sets where Spark either was really awesome and why it was awesome, or where it fell over maybe?
So I've used Spark in like two kind of different ways. So in consulting, you're usually on projects that like utilize very different parts of the workflow. So I've done a Spark data engineering type project where I was basically moving data in Spark, and I've also done Spark from a data science perspective. So from a data science perspective, it's much more fun because that's what Spark was built for, like especially Spark ML and all that stuff. From a data engineering part, it's not really meant for ETL, but people use it that way because it exists as a tool. And it can do things like convert data into ORC or Parquet or Avro, for example, but it's just a pain to do that. So the experience there was not so great, but I learned a lot, but the data science experience was cooler, but you don't get to like learn as much about Spark internals that way.
Could you clarify what you mean by data science?
Yeah, that's a good question. So data engineering is moving data, and data science is analyzing it. That's kind of how I see it. But there's also like a spectrum in between, right? So like usually as a data scientist, I'm moving data a lot of the time and cleaning it and all that stuff, and then at the end I get to analyze it. Data engineering is you're really worried about like tuning the performance of these systems and figuring out which system is the right one and worrying about file formats and all of that kind of stuff.
How mature do you see Spark? And do you think it's
Oh, I'm sure it'll be replaced by something.
in the next 2 years?
Possibly. Well, there's Flink. So if you're like super hipster, you can now move to Flink because this is like all mainstream. But I see Spark gaining a lot of ground, especially the fact that it is going to be an internal for Hadoop, particularly with Cloudera. Like that's a huge vote of confidence for it. There's a huge ecosystem of platforms, and most importantly, I see really big companies moving to it, which means it probably is going to be around for at least the next 2 or 3 years.
Having the full feature set that you like.
For what?
I remember I put Hadoop training in there, so I would buy all this wonderful stuff, and then you go, wait a minute, you're doing all this code because it doesn't have a having clause.
Yeah.
And so, but they're not willing to say, you can do this 3 queries if you don't have a having clause. Which I sell. How full feature is this?
I mean, I think it's maybe like, I don't know, don't quote me, but maybe 60 to 70% of what you would need right now. There's still a bunch of customization that you have to build in, but all the basic stuff has pretty much been figured out at this point because it's on Spark 2.0. Just like, I don't know, advanced machine learning stuff. It's not as fully featured yet because it's not, it's like a full system, right? It's not meant only for machine learning. It's meant also for moving data and doing basic analysis. So they haven't focused there as much. Like you're not going to get as much out of Spark as you would with R, for example, or SAS. even, but it's going to do the basics really well for you. Yeah. Yep. Yep. Yeah. All the stuff that you want. If you're doing neural nets, you probably don't want to do them in Spark, but I don't know because I'm like 3 months behind this. So what do I know? There's probably already like a super neural net. Yep.
Hi. So my question is, so big data is like a huge buzzword right now. What would you say the do's and don'ts are for people and companies trying to get into it?
I'd say this presentation. Do you mean like as an individual or a company that wants to choose big data, or?
I mean, if you have like a bunch of users and like data sets and stuff, how do you know if you really need to use big data mining tools, or is it even beneficial? How do you get the most benefit out of it?
I think you should start by looking at this, like how much data do you actually have, and do you need to use all of that data, right? So for example, if you have a ton of so I kind of work backwards. I ask the business like what their question is, because none of this stuff matters unless you're adding value to the company, right? Like we're not doing this just for the fun of it, although a lot of times I am because it's fun and cool. Your business is actually trying to answer a question like, how are our hospitals doing, or how many customers left our platform, or that kind of stuff. So like you have to get to the root of what that question is, and then figure out which data you need, and then kind of work backwards from there to build a system that's going to get you that data. Make sense? Yep.
So when you're talking to, I think you had SQL up there, were you talking about the LOE index?
Yeah. I don't think I had SQL. Oh, yeah. I have Postgres. Yeah.
So how does this compare against, really like drives
Well, there's no indexes and no SQL, which is why it's no SQL, right? So that's the fun of it. Well, yes, you're right. But in Hadoop, you can create Hive tables with potential indexes, but it doesn't work in the same way as an index in a database does, because really you're just compiling code to Java and you're running Java code. It's not really organized the same way a database is.
How does it compare to a graph database where the volume of data is volume of relationship?
So, they're used for different things. So Hadoop probably wouldn't be as good as a graph database for different things, but so you would want to use specific, like GraphQL or something like that. But I'm not too familiar. I haven't worked with graph data previously.
One comment to add to that is that graph database and relational database, they all have relationships. They all have defined relationship between data. Hadoop does too. It has a massive data. So you're setting agents loose to go through the count tally, organize as opposed to the others, where you're using it for this logic for which she ran that look at all of them.
Yeah, there's actually a graph database would actually be more the other extreme, more relationships.
Yeah.
Well, the has a concept of relationships. It's more referential, but that's kind of a middle ground.
Anyone else? Okay. Oh.
Just a general kind of question.
Yeah.
What's your biggest regret working in this space? What would you go back to yourself 2 or 6 years ago and say, no, don't do that?
I accidentally RF'd an entire Hadoop cluster once.
Okay,
So that's my biggest regret, but I don't call it a regret, I call it a learning situation. It wasn't productionized yet, and we also did not have any safeguards set up. So that was my biggest thing. But as to regrets, I have no regrets. The space is so fascinating and so interesting, and learning about it, it's really cool that I get to work with it. Okay. Cool. Thank you.